Hi, it's Curtis from Fingertech Robotics here. Andrea asked me to explain why speed controllers use PWM for power. That might sound foreign, but I've set up a little experiment and I'm going to try and explain it to you. This is a board I like to take to shows. It's basically the Viper robot without the chassis. So everything is laid out. You've got your transmitter, receiver, goes to your speed controllers. They're powered through your terminal blocks, and a battery is down there. Each one goes to a motor. Voila, and it's got a lifter as well. What I've done is disconnected one of the motors, and instead I'm driving it straight from a battery through a potentiometer. Now that's something that can change resistance based on how you turn it. So Andrea's already taught you that if you give a different voltage to a motor, it'll go a different speed. But inside your robot, there's only the one battery. So how do we control the speed of the motors from 0 to 100% in an efficient way? We're going to look at the wrong way first. And what I've done is set up my oscilloscope to show you the voltage that is going straight to the motor. Right now it's 7.4 volts. It's the full voltage of the battery. As I increase the resistance, you can see it drops down. We'll put it down to 4.5 volts. Now the motor's going about half the speed, which is great, right? Not so much. The way we've achieved that is by burning off half of the energy from the battery in this resistor. So in fact, you've got a lot less torque here. I can stop it with barely anything. And electronics don't like heat. So, burning it off in a resistor is not a good way to go. Now, what electronics are really good at is turning things on and off, and they can do it incredibly fast too. Once again, I've got the oscilloscope watching what's happening on this motor. That's showing up in blue. You can see a stream of signals. Each one, you can see there's a short pulse on, and then the rest of it is off. But as I push the stick up, the on portion gets larger and larger until it's all the way on. The white line here is actually showing us the average voltage. And so if we put it right around the same 4.5 volts that the other motor with the potentiometer was running at, you'll see that there's actually a lot more torque. It's full power. I cannot stop it with the finger the same way I was doing the other way, because we're not burning up half of our power in a resistor. So this happens, you might think, why is the motor not jittering or stuttering? This happens each pulse about 1,000 times a second, and basically the motor doesn't notice it. It sees pretty much just this average white line. So, your ESC electronically controls the speed of the motor by monitoring the signals from the radio receiver and modulating the width of the pulses of battery power to match what you're doing with the transmitter stick. Join us next time, where we'll teach you how to build your own speed controllers from scratch. Just kidding.